The ideal gas law deals with the equation PV equals nRT, Pivner, where P is the pressure, V is the volume, N is the amount of moles of a gas, R is our gas constant, and T is our temperature. So where many of our other gas equations deal with before and after scenarios, so for instance P1V1 equals P2V2, Boyle's law, 1 is your initial scenario, 2 is your final scenario, so you have a kind of a before and after situation, while Pivner actually just deals with one individual situation. So when you're given 4 out of your 5 variables, PV equals nRT, you can solve for the unknown variable. So really the only thing you shouldn't recognize in this equation is probably the R. R, again, is your gas constant. So R can have several different numerical values. So for instance, one R value is 0.0821 liters times atmospheres divided by moles times Kelvin. Another possible R value is 8.314 kilopascals times liters divided by moles times Kelvin. One more could be 62.4 liters times millimeters of mercury divided by moles times Kelvin. Now, the only real difference between all of these values is the pressure unit. So in the first one, we had a pressure unit of atms. Second one, we had a pressure unit of kilopascals. The third one, we had a pressure unit of millimeters of mercury. So these R values should always be given to you in problems. The only real issue that you'll have is making sure you use the correct numerical value for R depending on what pressure unit that you're given in the problem. So let's take a look at a problem here. A typical air horn contains 0.157 moles of gas and has a volume of 350.0 milliliters. If the temperature of the air horn is 22 degrees Celsius, what is the pressure in kPa? So here we want to define our variables. So we have P, V, N, R, and T. So when you look at what the question's asking for, what is the pressure in kPa? This is what we're solving for, our pressure. But if you notice, we have to have units of kPa. This is going to help us define our R value. So our volume here is 350.0 milliliters. And if you take a look at your units in your R value, you're going to notice that we have to change this to liters. So I know there's 1,000 milliliters in 1 liter. So the volume I'm going to use is 0.3500 liters. My value for N is 0.157 moles. My value for R needs to be my R value for kilopascals. So my R value here is going to be 8.314 kilopascals times liters divided by moles times Kelvin. My temperature is 22 degrees Celsius, so 22 degrees Celsius, and if you notice up above, my temperature needs to be in Kelvin according to my R value. So I'm going to add 273 to convert my temperature to Kelvin. This will give me a total temperature of 295 Kelvin. So at this point, it's just a matter of plugging my variables in and solving for my pressure. So my equation, PV equals nRT. Now, I like to solve for my variable before I ever plug in, so I'm going to solve for pressure here. So if I divide both sides by V, I cancel out my volumes, and I get pressure is equal to nRT divided by V. Now all I have to do is plug in and then calculate. So my pressure is going to be equal to N 0.157 moles times R 8.314 kilopascals times liters divided by moles times Kelvin times T 295 Kelvin. I'm going to divide all that by my volume, which is 0.3500 liters. So if I look at my units, moles cancels out with moles, Kelvin cancels out with Kelvin, liters cancel out with liters. I'm left with units of kPa. The pressure is equal to 1100 kilopascals.